Hello everyone, this is Vartman and welcome back. So this video will be going to about complexity classes. Here we will get to know about how we can compare different functions which is bigger or which is smaller, and this comparison will help us in our future learning when we have to compare complexity of different algorithm to find the best algorithm among them. So let us begin. So I have already written here different type of functions and I have arranged them in increasing order. So let's see them one by one. First we have our decreasing function. So 1 upon n, 1 upon n square, 1 upon 2n. These all are decreasing function. So these are the smallest function in our list, and we have arranged the lists in such a way that at the top we have the smallest function and at the bottom we have a larger function. So this list is arranged in increasing order. So we can follow this. On number 2 we have constant. So 1, 2, 3,000, these all are constant, and this is the second. At third we have log of log n. At fourth we have log n. Fifth we have under root n, or we can write it as n raised to the power 1 by 2. Sixth we have linear function, and then we have quadratic function, cubic function, then we can say all polynomial function will come here, raised to the power 4, 5, 6, or these will be polynomial function. And at last we have exponential function, which is 2 raised to the power n or 3 raised to the power n. On the right hand side we have some relations. First one is n is smaller than log n raised to the power log n. Second is n factorial is greater than 2 raised to the power n is smaller than n raised to the power n. So these two, n factorial and n raised to the power n, they are nearly equal, and we can sometime write n factorial equal to n raised to the power n. So in the questions we will use these two. And for next we have log base 2n is greater than log base 4n. So in log, if the power is small, then that is large. So log base 2 will be greater than log base 4. Next we have exponential function, which is 2 raised to the power n or 3 raised to the power n. So here 2 raised to the power n will be smaller than 3 raised to the power n. Let's solve few questions to apply what we have learned so far. So we will be applying asymptotic notation and complexity classes here. So these questions are true or false type of question. So let's solve the first one. So first we have 2 raised to the power n plus 1 is equal to theta of 2 raised to the power n. We have to check if this statement is correct or not. We can write 2 raised to the power n plus 1 as 2 raised to the power n into 2. So which will become 2 into 2 raised to the power n. We can write it this way, and when we compare it with 2 raised to the power n, so there is only a constant difference. So this statement is correct. It is theta. Next is the second question. So here we have 2 raised to the power 2n, and which is equal to theta of 2 raised to the power n. So let's check here. 2 raised to the power 2n can be written as 2 raised to the power n plus n, which can be written as 2 raised to the power n into 2 raised to the power n. And here on the right side we have 2 raised to the power n. So this is clearly not a constant difference, it is a function difference, and this value which is on the right side is greater than 2 raised to the power n. So this is not theta, but this is omega, because 2 raised to the power n is smaller than 2 raised to the power 2n. Let's look at the third question. So we have 4 raised to the power n upon 2 raised to the power n, and they are saying it is equal to theta of 2 raised to the power n. So let's check. 4 raised to the power n upon 2 raised to the power n can be written as 4 upon 2 whole power n, and this is equal to 2 raised to the power n. So we can say left hand side and right hand side both are equal. So in this case this is theta. So if it is theta, then we can say it is omega also, and it is big O also. Let's look at the fourth question. Fourth question is 2 raised to the power n is big O of n raised to the power n. So they wanna say that 2 raised to the power n is smaller than or equal to n raised to the power n. So let's look at our complexity classes for 2 raised to the power n and n raised to the power n. So here we have defined 2 raised to the power n is smaller than n raised to the power n. So we can say here 2 raised to the power n is smaller than n raised to the power n. So in this case, this is big O, but this will not be omega, and if it is not omega, then it will not be theta also. Let's solve the fifth question. So we have 2 raised to the power n equal to big O of n raised to the power log n. So here we have to prove that 2 raised to the power n is smaller than or equal to n log n, n raised to the power log n. So let's solve it. Here we have 2 raised to the power n, and here is n raised to the power log n. We will take log both side. Log base 2, 2 raised to the power n equal to log n raised to the power log n. So here n will come in front. We will have log base 2 2, and here will be log n into log n. Log n will come in front in this also. This can be written as 1. So here we will have n, and this will become log n square. So here n is smaller than log n square. So let's check. So we can square root both side. This will become under root n, and this will become log n. So we have seen this in our complexity classes, so let's go through that. So we have log n first and then under root n. So log n is smaller than under root n. So here log n is smaller than under root n. So we found out log n is smaller than under root n. But we need greater than. So this will not be big O certainly. This is not big O, but this can be omega. Let's see the sixth question. So we have n factorial, and they are saying n factorial is small o of n raised to the power n. So in our complexity classes we have seen n factorial is nearly equal to n raised to the power n. So it is not equal, but it is nearly equal. So we can say n factorial is smaller than n raised to the power n. So here this will be small o. Let's check for big O. So to be big O, we have to satisfy any of the two condition, which is it should be smaller than or equal to. So in small o, we already satisfy the condition that it is small. So we can say it is big O also. So let's take an example. If A is big O of B, so can we say that A is also small o of B? So let's check this. So to be big O, you have to satisfy two conditions. Either it should be A is equal to B, or A is smaller than B. If it satisfies this condition, A is smaller than B, then we can say it is small o. And if this condition is satisfied, A equal to B, then it will not be equal to small o, because small o only needs one condition, that is smaller than. So we cannot say to be certain that it satisfies only this condition. So it can be either of the one condition. So A will not be small o of B. But the reverse is always possible. if fn is small o of gn, then it will always be the case that fn is also big O of gn.